Hey everybody, welcome to Geometry 2, Section 12.5, Equations of Circles. By the end of this lesson, you should be able to tell the center of a circle and radius from the equation, graph a circle from the equation. You should also be able to write the equation of a circle from the center and the radius, the graph, and the center and a point that's on the circle. So let's talk about the equation of a circle. We've talked about the equation of a line, which has the formula y equals mx plus b. Even a parabola has the formula y equals ax squared plus bx plus c. Even a lesser known absolute value, y equals the absolute value of x, looks like a v shape. So what about the equation of a circle? So here we have a circle on a graph, and it's going to look a little bit different than the other ones. All the other ones had y equals. Well, this one's going to be slightly different. It's going to be x minus h squared plus y minus k squared equals r squared. Okay? So a lot of squaring going on. The x and the y are on the same side. And you might be wondering, well, what the heck is h, k, and r? Because, of course, x and y are in all the equations. So you have to have x and y. But what the h and the k represent is the center of the circle. Okay, so when you see an equation, you'll actually have numbers in for the h and where the k is, and those numbers will represent the center. That's the most important point of any circle, is the center. So that's got to be the first thing that we identify. Now, the only other thing that you need in order to make a circle is the radius. And of course, that's what r is going to be. Now notice the formula says r squared, all right? But then the radius is just r. So that means once you see that number at the end of the equation, you got to take the square root of it to get the actual radius. So, for instance, on this particular graph, we see that the center is -2 and then up 6. So the center is -2, 6. And then the radius looks like 1, 2, 3, 4, 5. Looks like the radius is 5. So now that we know the center and we know the radius, we can actually use that to write the equation of the circle. So since the x-coordinate is -2, what I'm going to do is I'm going to take that -2 and I'm going to plug it in for h. And then I'm going to take that 6 and plug it in for k. So now I've got x minus -2 squared plus y minus 6 squared equals r squared. Now I can also take that 5 and plug it in for r. And now what I have, let's just clean it up a little bit. So in the first set of parentheses, the x minus -2, of course, that can change into x plus 2. And then the 5 squared can change into 25. So there's my equation. X plus 2 squared plus y minus 6 squared equals 25. Now something I want to note here is that notice how the center is -2, comma, positive 6. And in the formula, it's x plus 2, and then y minus 6. So whatever the actual coordinates are for your center, in the formula, in the equation, they're going to be opposite signs. Okay? Remember that. So let's go ahead and take that same equation, and let's do the same thing. Here we have a center and a radius. Let's go ahead and plug in that information and figure out the equation of this circle. So I plug in the 2 for h, so now I have x minus 2 squared. Plug in the -5, and remember, because it's a -5 and the signs change, it'll come out as a plus 5 in the equation. So now I've got plus y plus 5 squared. And if the radius is 7, then I need to put equals 49. And there's my equation. So if you have the center and the radius, that's probably the easiest possible situation. So now what if you don't have the center and the radius? What if you have the center and then a point on the circle? And this is probably going to be the most difficult aspect of it, is because we don't have the radius and we need to find the radius. So if I've got this random point on the circle and I've got the center, the way I can find the radius is to find the distance between those 2 points. So that brings back our old friend from chapter 1, the distance formula. So what I'm going to do is I'm going to take the center and the point on the circle. I'll call one of them x1, y1, the other one x2, y2. Let's plug those numbers in to our distance formula. So I'm going to do the x's first, so x2 minus x1, so 1 minus 4 squared. Then let's do the y's. So then y2 minus y1, so 5 minus 9 squared. And let's work that on out. So when I subtract, I get negative 3 in the first set of parentheses and negative 4 in the second. Square those up. And remember, when you square a number, it always comes out positive. So negative 3 squared is not negative 9, it's positive 9. And then negative 4 squared is a positive 16. Add those two up, and I've got the square root of 25, which is 5. So I know that distance between those 2 points is 5, which means the radius is 5. So now I'm at a situation where I was before, where I have the center and I have the radius. So all I got to do now is just plug it in. So x minus 4 squared. Let's take that 9 and plug it in for k. So y minus 9 squared. Let's take the 5 and plug it in for r. So 5 squared is 25. And there's my equation. X minus 4 squared plus y minus 9 squared equals 25. So let's go ahead and work a few examples and see how this goes. All right, so let's take a look at this. It says write the standard equation of each circle. So in question number 1, they give us the center and the radius, easiest possible scenario. So I will write x minus 7. Remember, because it's a positive 7, when it goes in the formula, it changes signs. And then if my y coordinate's negative 3, I put y plus 3 squared. And then I square that 9, and I get 81. And there's my equation. Easiest possible scenario. Let's take a look at number 6. So my x coordinate is negative 5, so I'll put x plus 5 squared. My y coordinate's negative 4, so I put y plus 4 squared. Now, if my radius is square root of 3, and I go to plug that in, when I take that square root of 3 and I square it, the square and the square root cancel out, so I just end up putting 3. All right, so there's my equation. X plus 5 squared plus y plus 4 squared equals 3. The problem looked tougher than what it actually was. All right, so now the next set of questions says take the circle from the diagram and let's go ahead and write the equation. So let's go ahead and do circle A. So for circle A, my center, it looks like I'm going backwards 4 spots. So first thing I'm going to do is I'm going to actually identify what's the center and what's the radius, and then plug it into the formula. For my y coordinate, it looks like I'm going down 4 spots. So it looks like my center is negative 4, negative 4. And my radius, looks like I have a radius of 2. So then my equation for circle A is going to be x plus 4 squared plus y plus 4 squared equals 2 squared, which is 4. Okay. Let's go ahead and do circle B while we're at it. So for circle B, my x coordinate is negative 1, and then looks like I go up 2. So my center is negative 1, positive 2. And my radius, if I go from the center 1, 2, 3, 4, my radius is 4. So once I've identified those two things, it's real easy. Just plug it in. So x plus 1 squared, and then y minus 2 squared. And I can see some people messing up on this and saying, okay, so if radius is 4, then I put 2. We don't square root it, we square it. So that would make 16. All right. All right, so let's get to probably one of the more difficult problems. Write the standard equation of each circle with the given center that passes through the given point. So this is the one where I have to use the distance formula in order to find the radius. So I have my center, which is good. But then for my distance formula, I have to do, let me go ahead and label this, x1, y1, x2, y2. So the first part is x2 minus x1, so 9 minus 6 squared. And then y2 minus y1, so 12 minus 4 squared. So 9 minus 6 is 3. Uh, 12 minus 4 is 8. So I get 9 plus 64. And so then my radius, if I add those two up, I get 73. So square root of 73. Now, I've got my radius, I've got my center. Let's change colors up a little bit. So I'm going to use that point and plug it in, and I get x minus 6 plus y minus 4 squared. Now when I take the square root of 73 and then I square it, the square and the square root cancel out, and so I just put 73. So even though when we were doing the distance formula, it didn't come out nice, neat, and perfect, it all worked out in the end. Last thing I want to do, let's go ahead and take an equation and use it to graph the circle. So this is just the reverse process of what we've been doing. Let's take the equation and use that to identify the center and identify the radius, and then we graph it. So my center is going to be the coordinate positive 2, comma, positive 3. And then since it equals 9, that means my radius is 3. Okay, hopefully that makes sense how we got that information. So now we go ahead and plot it. So over 2 and up 3. There's my center. If my radius is 3, the way I graph that is I just go over 3 and then backwards 3, up 3, down 3. I make all 4 of those points. And then I just connect them. Let me use a different color for that. Now what I'll see some people do is once they make those 4 points, they start to connect them, they go, and it looks kind of boxy, kind of round. I don't like it. So what I do is I kind of make a little curve here, a little curve here. And that makes it a little bit easier to see the circle. There we go. All right, there's my circle. Let's try one more of those. So my center is going to be the coordinate -1, comma, -5. And since it equals 4, my radius is 2. So go -1, -5. There's my center. Go out 2 in each direction, left, right, up, and down. Make the curve, and then connect it. And there's my circle. Hopefully this lesson wasn't too bad for you. I think it's fairly straightforward, but let me know what you think. Either ask me questions in class or email, and I'll be glad to help you in any way possible. Hope you guys are doing well. This was our last lesson for the year, so I'm pretty pumped about it. Hope you guys are doing well. Have a good one. See you real soon.